So in this problem, we're asked to draw the shear moment diagrams for this gantry that's supported with these two cables, A and B. So what we're going to want to do first is we're going to want to draw a free body diagram. So our first force here is this 60 pounds down right at the very beginning. And then 2 feet after that, we have this downward force of 80 pounds. And we also have this cable, which is going to give us a tension force. And this tension force is going to be up. And we're going to call that tension A. And these are 2 feet apart. And then we go another 8 feet without any forces, and then we get another 80 pounds downward force. 8 feet over. And then another 5 feet over, we have another downward force of 80 pounds. 5 feet. And then 3 feet after that, we have this upward tension force at B, which we're going to call tension B. And then on the very end of the beam, the very end, which is 2 feet over from the last force, we have downward 60 pounds. So now when we have our free body diagram, we're going to want to find our force of tension A and tension B. So we're going to use our equilibrium equations to do that. We're going to start with the net forces in the y direction, and that's just pretty simple. We're just going to take all the forces that are pointed up or down, and we're going to either add them if they're pointed up, like the tensions, or subtract them when they're pointed down. So we're going to start off over on this side, 60 pounds. It's going to be negative because it's pointing down, and then minus 80 pounds because it's pointed down, plus tension A because it's pointed up, minus another 80 pounds right here, minus another 80 pounds, plus tension B, it's in the upward direction, minus 60 pounds, which is this at the very end because it's pointed down. So, and this is gonna be equal to 0. There's no movement in the y direction, so we know it's gonna be equal to 0. And here we can't solve for tension A or tension B yet. We don't have enough equations for that. We have 2 unknowns and 1 equation. So we're gonna want to take the moment around A. So A is right here. This is where we'll be taking the moment around. And we don't have to account for tension A or the forces in line with A, which is nice because it's going to be able to give us tension B here. So we're going to start with this 60 pounds, and this is going to create a counterclockwise rotation, so it's going to be positive. So that's going to be 60 pounds times 2 feet, because it's 2 feet away from A. And then we're not going to have any other forces create a moment until this other 80 pounds. And that's going to create a moment in the clockwise direction. So when it's creating a moment in the clockwise, it's negative. So it's going to be 80 pounds minus 80 pounds times 8 feet. It's 8 feet away from A. And then again, another negative 80 pounds times 8 plus 5 is 13 feet. It's going to be 13 feet away from A. And then we have tension B, which is going to create a counterclockwise rotation around A, and it's going to be positive. So tension B times 8 plus 5 plus 3 is 16 feet. And then we'll be subtracting 60 pounds times 18 feet, because it's 18 feet away. And again, it's going to be equal to 0. There's no moments going on. And then we're going to take our equilibrium equation of the moment around A, and we're going to use that to solve for tension B. So doing that, we get tension B is equal to negative 60 times 2 plus 80 times 8 plus 80 times 13 plus 60 times 18, and divide that by 16 feet. And then when we solve for that, we're going to get tension, we're going to get tension B is equal to 165 pounds. So that's what that gives us, and we're going to use this value. We're going to plug that into our net force of the Y equation to get tension A, and when we do that, we get tension A is equal to 195 pounds. So those are going to be important. We're going to want to make sure that we're using those in our moment and shear diagrams. So we'll go, and from here we can move on to those. Okay, so now that we found our tension A and tension B, it's a good idea to redraw our free body diagram. So what we're going to have this downward 60 pounds. That hasn't changed. And then from there we're going to have downward 80 pounds. And we're going to have our upward of 195 pounds, because this is A, right here, this is A. And then these are going to be 2 feet apart. We're going to want to make sure that we know the increments between these, because that's what we're going to use in our shear and moment diagrams. So we know that those are 2 feet apart. And then we don't have another force until way over here. And that's a downward force of 80 pounds. And those are 8 feet apart. 8 feet. And then after that downward force of 80 pounds, we're going to have our other 80 pounds down. 80 pounds. And that's 3 feet over. And, oh sorry, that's 5 feet, not 3. That's our 5 foot, 5 feet over. And then the 3 feet over, that's going to be this tension B of 165 pounds. And that's 3 feet from the other point. And then from there we have our last downward force of 60 pounds. And that is 2 feet from tension B. Okay. So now that we have our updated free body diagram, we're going to want to work on our shear diagram first. So we're going to start off down here. We're going to go down 60. So right here, we're going to get negative 60 is our starting point. And it's going to be a straight line, no new forces, nothing, until, so we're not going to have anything to take into account until we get over here. And so that's just going to be a straight line. And so here we have an upper force of 195 pounds and a downward force of 80. So we're going to subtract 80 from 195, which gives us 115, and then we're going to add 115 to negative 60. So doing that gives us positive 55. So from there we have no other forces, there's nothing going on until over here. So it's a straight line until we get here. And we're just going to subtract 80 from 55, which gives us negative 25. So this negative 25, same thing, nothing's going on until we hit this other negative, or a downward force of 80 pounds, subtract 80 from negative 25, gives us negative 105. And then we're not going to have any other forces until this upward force of our tension. So our tension force is 165 pounds up, so we're going to add 165 to negative 105, which gives us positive 60 pounds. And this ends up working out because our last force over here is a downward force of 60 pounds. And this is going to bring us right back down to 0. And that's a good check to make sure we did everything right. And this makes sense. We end at 0. It means we're at the right spot. So now we're going to move on to our shear diagram. So for our shear diagram, that is going to be in foot-pounds. So we have our foot-pounds, and we're going to start. This is pretty simple. We can just do area under the curve for all of our situations here. So we're going to start with this area right here. So this is going to be negative. This is a negative value here. So that means our slope is going to be downwards. It's going to end up down. And it's linear because this is it's just going to be a constant slope. It's a constant rate of change. And so our area under the curve is going to be negative 60 times 2. So that's going to be negative 120 there. And then we don't have any other forces to take into account. We don't have any moments going on. So we're going to want to take the area under the curve for this section, which is going to be positive, which means our slope for our moment diagram here is going to be positive. So the area under the curve for this is 55 times 8. We're staying at the steady 55, spanning 8 feet, base times height, 55 times 8. And when we do 55 times 8 and add it to negative 120, we end up getting positive 320. And that's going to be a straight line. It's going to be linear. And then same thing over here. Take the area under the curve of this section, which is negative. So our area under the curve for this is negative 25 times 5, and negative 25 times 5 is negative 125. So 125, you're subtracting 125 from 320, and that's going to give us a value right here of 195. And then we're doing the same thing here. This area under the curve is also negative, and this is negative 105 times 3. So we're going to do 195 minus 105 times 3, which gives us this same 120. So it's just it's going to be a line. These are all linear. We can see that because they're just straight. These are all straight lines. There's no slopes that we have to work with here, really. It's just constant. And then lastly, 60. We have the area under the curve for this, which is positive. 60 times 2 is positive 120. So negative 120 plus 120 gives us, it's going to end up giving us 0. And that's a great check because when we end up at 0, we know that we did it right. There's not supposed to be any moments at the end. So it's a good check, and we know we did it the correct way now.